So we have another problem. So consider the boundary value problem introduced in the construction of the mathematical model for the shape of a rotating string d squared y over dx squared plus rho omega squared y equals to 0, wherein y to the 0 is equals to 0 and y to the l is equals to 0. For constants t and rho, define the critical speeds of angular rotation omega n as the values of omega for which the boundary value problem has non-trivial solutions. Find the omega n and the corresponding deflections yn to the x. So to solve the problem, we have d squared y over dx squared plus omega squared y over t is equals to 0. So at first, we will change this equation to y to the double prime plus omega squared y over ty equals to 0. So now, we will differentiate y to the double prime. So we let y equals to e to the mx, y prime equals to m e to the mx, and y to the double prime equals to m squared e to the mx. So now we will now substitute y to the double prime equals to m squared e to the mx. So we will have m squared e to the mx plus omega squared over t e to the mx equals to 0. So now we will factor e to the mx. So we will have e to the mx times m squared plus rho omega squared over t equals to 0. So since e to the mx is equals to 0, so now we will have m squared plus rho omega squared over t equal to 0. So we can now get the m, which is positive negative square root of rho omega squared over ti. So now we will have our equation, particular equation, y equals to c1 cosine of rho omega squared over tx plus c2 sine square root of rho omega squared over tx. So since in our problem we have y to the 0 equals to 0, so we will have 0, y, and x will be 0. So sine of 0 is equals to 0. So we will eliminate c2. And cosine of 0 equals to 1. So we have 0 equals to c1 plus 0. And now we can now get c1 equals to 0. So we can now solve the problem. So we will now get 0 equals to c1 cosine of square root of rho omega squared t l plus c2 sine square root of rho omega squared over tl. So since c1 is equals to 0, so we can eliminate this equation. So we will have, so we can only focus here, c2 sine square root of rho omega squared over tl. So now we will now focus in this equation. So what will be the values that makes this sine square root of square root of rho omega squared over t equal to 0? So we have 0, pi, 2 pi, 3 pi, and furthermore. So we can get n pi. So focusing in this equation only, since we can eliminate this equation since c1 is equals to 0, so we will have square root of rho over t omega l, since omega since rho omega squared and it is square root, so we can make it omega l equals to n pi from what I explained earlier. So omega n equals to n pi over L. So we only simplify it to get the omega. So this is the result. N pi over L square root of rho over T times T over T. Since this is radicals, so we already learned radicals, so we will get Wn equals to n pi over L square root of rho T over T equals to Tn pi over L square root of rho T multiplied by another radical equations, square root of T over square root of T. So our final answer will be Wn equals to n pi square root of T over L square root of rho, wherein n equals to 1, 2, 3, 4. So this is our rho to n. So we only have the first answer, rho n. So the second answer would be, now we will go back to our equation, y equals to c2 sine square root of rho omega squared over t x. So now we already get the omega n. So we will only substitute omega from our answer in the previous, from omega n here. So we will get y equals to c2 sine square root of rho over t, and from the omega, which is n pi square root of t over L square root of px. By simplifying it further, we will get y equals to c2 sine n pi over Lx, where c2 must not be equal to 0. So this is our final answer.